What up, peeps? This is McMullen again with interval notation. Just a quick follow-up on the last video. Previously, we looked at the use of a double inequality and how to describe a double inequality using interval notation. This time, we're going to take what is ostensibly an easier concept. And we're going to talk about how to do that in interval notation. This time, I'm going to go ahead and graph on here values that are strictly greater than -3. And as you can see, this time, we don't have an upper boundary. The boundary doesn't exist. So if I was going to write this as an inequality, I'd write x is greater than, strictly greater than -3. So when I do interval notation, I'm accustomed to starting with the lower boundary point. And of course, this time it's going to be a parentheses because it's an open. But the question is, what do I put over here to indicate that I don't have an upper bound? And in this case, what we say is that any value greater than -3, all the way up to infinity and beyond, right? Handle the Buzz Lightyear there for a moment. But infinity, of course, not being a number, it's just a concept representing that numbers never stop. We write infinity here. And then, as a rule, whenever we're using infinity in our interval notation, we always put parentheses, because the bracket kind of implies that there is an endpoint and that the endpoint is included in the interval. And of course, in this case, infinity is not itself a number. It can't be the end or boundary point for the. So that's how you show a single inequality using interval notation.